Alright. So, per your all's many suggestions, or at least the two that I gathered in class, was that it wasn't well lit enough. It's too dark. I did it yesterday morning at about dawn. And it was too loud. So, it's a little bit later in the evening. What's my watch on? There it is. It's almost 11 o'clock. And what I'd like to demonstrate is the same thing I showed you yesterday. So we're better lit. It's late at night. The chances of us having to be distracted by cars or whatnot will hopefully be a little bit better than they were yesterday. Okay, so what are you doing, Mr. Quinn? Well, once again, I'm filling my hose completely with water in an attempt to create a siphon. That's right, the same siphon that you saw yesterday. Now remember, gravity, the weight of the water pulling downward creates a force that pulls, here we go, water out. Now you see, if we wait long enough, it'll actually pull a full stream. Now, pause the video, pause the video, and go find and Google yourself a stopwatch. I guess I should say start. That would make more sense. Alright. Start your stopwatches on the count. Let's get it going again. I'll just bring it over. Let's make sure that we've got a good flow. That looks pretty good to me. So on 3, 2, 1. Do-do. Do-do. Well, I believe our time yesterday was like 1 minute and 32 seconds, and then it was crazy. It was like 32:32. And the probability, it seems like, that happening is pretty slim. Pretty slim. 1 in 1,000, maybe? Maybe 1 in 10,000, now that I think about it. Anyway, that's for after Christmas. Alright, looks like we're almost halfway. 2 quarts. 2 quarts of the way is halfway. 2 quarts is half a gallon, so what is a full gallon? What is a full gallon? I got old man back. It's getting worse. Getting closer. Getting closer. Hope you guys are keeping your fingers right next to your mouse button, so when I say stop, you will stop on a dime. Alright guys, now we're at 3/4 of the way full. And as soon as it reaches the very bottom, the very tip of the blue, then that will be 4 quarts of full gallon. And 3, 2, stop. Alright, well, that was fun. That was the white one. And now for another good time, let's pour the water back in. Now remember, if you want to play this game at home, if you want to help me collect some data, some scientific important data, in an attempt to demonstrate an Aristotelian physics concept, then I know you will. Find yourself a length of 4-foot hose that has some characteristics. Alright, in we go. let it bleed out a little. Oh wow, it's going good right away. Alright, in 3, 2, 1. Go timer. Go, go, go timer. And you're just going to have to take my word for it. Sorry, I moved it around. 3, 2. Stop. Oh, I don't know. I think we may have messed up our experiment. I did. And because this is, if it was the white one, I probably wouldn't do this. But because it's the black one, I'm going to. We'll do that one again. If you heard that sound, it was me sucking water or air off the bottom of it. So, to be precise, because nothing's really worth doing if you're not going to do it right. To be precise, let's try it again. All right. So, whatever that time you recorded, 86. We don't need it. Because we're going to generate more precise and more accurate data points. All right. Here we go. All right, let's bleed it out, make sure we're good. That looks good. All right, well, 3, 2, 1. I'm trying to pull a quick one here. Thinking it was a pinky. All right, coming up quick. 3, 2, and 1. Ta-da! So there you have it, friends and neighbors and friends. Now remember what we're trying to do, or some things that we'd like to think about, or maybe just some things I'd like you to think about. however you want to phrase it. I'm sure Sam would love to have a chance to rephrase it for me. I might ask him to. There are natural laws on the planet and in our universe, and they follow Aristotelian laws. This is Aristotle. All right, they're all kind of based off what he calls natural laws. What we're witnessing or demonstrating today is another natural law, and it's very closely well, it is physics. It's not related to it. It is physics. So what we're just trying to do is explore physics and a natural phenomenon by examining mathematical data. And one of the best ways to do that, I think, for this class, for 7th grade math, is to look at, how shall we put this, the relationship between numbers and how they measure. I want to put this correctly, guys. I want us to use math to measure natural phenomena. And let's just make some explorations. The neat thing about science is that it has to be repeatable. So if you have nothing else to do this weekend, and trust me, you don't have anything else better to do, get your parents to dig out you some 5-gallon buckets, or even, it doesn't even require a 5-gallon. You can just use a mop bucket and play around with this concept. Maybe you can find your own 4-foot length of hose, or whatever length. Really and truly, you can use your garden hose. But I want you guys to start thinking about some big ideas, because, quite frankly, I'm bored with unit rates.